Hey, Chris, do you need any of this on this board?
Hello.
Okay. Oh, there we go. We're starting to get some of y'all here. Pull up my chat.
Hello.
Okay. Sorry, guys. I am trying my bestest to get all this set up. We have been in chats all day today with the loveliness of, this new mandate that just came out with Mr. Abbott and his new thing about we're not doing anything until the 4th. It just has gotten real fun real fast. So my goal tonight is to do sections 4.4 and 4.5. Is the two sections that I am planning on trying to cover. Hopefully, this won't be too long of a session, since it is only two sections that are being covered tonight. Same gigs as before. If you got questions, pop them over there into that chat, and I will answer them just as soon as I see them, and have a break and pull in and make sure that, because I don't want to get too far away from whatever you're asking a question on. I will also be uploading this to YouTube and then providing the link for it in Canvas with that, so that if you want to go back and view it or anything like that, or if you are talking to anybody, social distanced, talking to anybody that may also be in our class, that they are going to be up on YouTube. I try and make sure that they're in there. I also put an announcement out today, because of that new mandate from Governor Abbott. Tests are going to get a little different now. I'm going to do some talking with my department chair and a couple other people in the department and find out kind of what their ideas are, what my ideas are, see if we can come out with kind of a nice level playing field, so that we can adequately check your ability of knowledge of the topics, but at the same time, trying to keep it in a platform that is workable, and that kind of stuff. So I'm going to send a message out a little later this week about that. And again, I'll post it all up in Canvas. All of this will come out through Canvas, and as all of that goes through. So I'm going to go ahead and switch over to my whiteboard. Okay. So we have, section 4.4, we're going to start with solving exponential equations. And there's two ways that we're going to do this. The first option is that we can get these into the same base. Our second option is going to be, if we can't get them into the same base, is going to be that we're going to have to use a log, okay, to help make this stuff happen. Now then, as we process through, and we're going to start with the same base ones, as we process through with same bases, I'm going to kind of step the levelings up, okay, as this is processing through. So kind of the most basic version of this that you'll see, and then moving upwards as we go, okay? So if we start off with something that looks like this, okay, just kind of playing matching parts and pieces. If the 4s match and we have an equal sign, then whatever's up here in the exponents must also be the same. So x must equal 2. Now, okay, so now then, the kind of rule behind this, okay, is if I have b to the m equals b to the n, then m has to equal n. Okay, trying to find a marker that's going to show up well enough for you guys. Okay, now note what has to happen there. These bases have to be the same. Okay, so if they're not the same, we got to start trying to figure some stuff out. Okay, so taking a look at a couple of examples. Okay. So I've got 5 to the 3x minus 6 equals 125. Okay. So now then, one of the things to make note of is you are never going to take a small base up to a larger number. You're going to have to bring the larger number down to the smaller base. Okay. So the question now becomes, can I rewrite 125 as a power of 5? The answer is yes. 5 times 5 is 25. Times 5 is 125. So we're going to rewrite this as 5 to the 3x minus 6 equals 5 cubed. Okay, now the 5s match, which means I can get rid of them. So now we have 3x minus 6 equals 3, and we're just going to finish solving for x. So we'll add 6, divide by 3, it's down so you guys can see. Don't put me a mark so I don't know how high I can go. Okay, so there's our answer for this. So now then, taking a look at another one. Okay, now here is the concern that we have with this one. My smaller base is 4, but I cannot do 4 to a power and get 8. If I do 4 squared, that's going to send me all the way up to 16. So the concept here is, can I bring both of these bases down to something smaller, okay, to a smaller base that I can do? And so thinking about that, we think about the base of 2. 2 times 2 times 2, or 2 cubed, will give me 8. 2 squared will give me 4. So the way that we're going to handle this is we're going to redo the 8 as a 2 cubed. Whatever was up there in that exponent, we're going to put in a set of parentheses. And over here, we'll rewrite 4 as 2 squared. And again, whatever was up there in a set of parentheses, whatever was already in the exponent is going to go up to a set of parentheses. Okay? So now, again, our bases of 2 match, so we don't have to pay attention to them. So we're going to take our exponents, okay, and bring them down to deal with them. We're going to distribute. Okay. I'm going to move my 2x this way. I'm going to subtract 6. And I get negative 12 for that one. Okay, now, guys, this is kind of the most involved one that you would have, where you would have to have both bases are having to be brought down to a smaller base in order to make that happen, okay? So the next type that we are going to look at, okay, is going to be when we can't get these to match up to the bases, okay? So starting forward, okay, I'm just going to present the problem first and then show you kind of how we would deal with it. Okay, so we've got 5 to the x equals 134. Now, here's the concept. 5 squared is going to be 25. 5 cubed is 125. 5 to the 4th is 625, okay? Now, I'm not going to be able to get anything that is 134, okay? So the way that we do this is, okay, I want to be able to get this exponent, okay, so the x, where my variable is, I want to be able to get it down out of the exponent, okay? But I don't have a way to do that right now. Now, if you think back, okay, or you watch the video from section 3.3 where we were discussing logs, okay, one of the rules was the power rule. And the power rule said if I had log of something with a power, I could bring that power down in front, okay, and it would get it down out of the exponent. Now, the problem is this doesn't have a log in it, okay? That's fine, because what we can do, log is an operation. It's kind of like square root. So what you can do is you can take the log on both sides. Now, traditionally, we're either going to use common log, which is this one. Remember that common log, they do not put a base on it, okay? They don't have that little subscripted base on here. It is an understood base of 10, okay? This is also the one that on a calculator, this is the log button on a calculator, okay? Or we will use natural log. Natural log is that LN button that is on our calculator, okay? When we're doing that. So now that I have this done, the X can come down out in front. Okay. Now, the connection between X and log 5 is multiplication. So I can divide what I don't want. Now then, one of the mistakes that students make is they want to try and cross off this log word. You cannot cross off the log word, okay? You cannot cross this off, okay? It has to stay this way. Now, this, with the word log in it, left just like this, is called an exact answer, okay? Now then, sometimes they will ask you to put an exact answer in. If they ask you to do this, that means they're looking for answers that have the word log or natural log in them, okay? One of the two. Now, sometimes they will ask you for a decimal approximation. If they are going to ask you for a decimal approximation, okay, looking at our lovely, pretty little calculator here, I'm going to do log. It's right over here by the 7 button. Oops, let me turn on. I'm going to do log 134. Make sure you close that set of parentheses because you are done with 134. Then we'll do divide by log and then 5, and we're going to close that set, okay? Notice this looks very, very close, okay? Trying to get these both in the same screen to that, okay? And then we'll press enter, and we get 3.043, okay? Okay, and this is our decimal approximation, okay? Now, one of the ways, okay, that you can check yourself, okay, if you were going to want to try and check yourself on this, okay, is you can take on your calculator and go back in and plug this back into the original thing. So if I do 5 raised, okay, and again, I use my little caret button for that, 3.043. Now, I'm using a smaller cut off version of this, which means I may be a little off in my answer, but I get 133.95. That is really, really close to my 134. And if I'd been more if I'd used more decimals here when I was doing my check, then I would probably be a little bit closer to that 134, if not spot on, okay? Now, there are a couple of instances where the problem that we are given kind of lends us to using one log version over the other, okay? So in this case, my base is 10, okay? If I use common log on this, okay, the thing that happens is when you have common log, which remember has an understood base of 10, okay, when you use this against this, those two parts cross off. That leaves me just the x. Okay, and this rule, okay, moving from here to here, was in a chart that is at the end of the PowerPoint or close to the end of the PowerPoint for 4.2. Okay, so in 4.2, we have that one, okay? Now, again, this is our exact answer. If we go to our calculator, this one I don't have to do anything special other than log 8,000. Oh, sorry, 1 too many zeros. Close that set of parentheses and press enter. And I get 3.903. And that is our approximate. Okay. Again, if they ask for an exact answer, they're looking for the word log to still be in there. Okay. Hopefully everybody's good so far. Okay, now, next one that we're going to look at okay, this is one where you're going to have to do a little bit of solving first before you actually get into the step where you're going to bring the log in, because I need to get this E thing by itself before I can bring a log in. So first thing, guys, if that was an X, okay, so I had 40X minus 3, first thing I would do is add the 3. Be 240. Next, I'm going to divide the 40 off of the front because the 40 is not included in this exponent. This exponent only applies to the E. So now we're going to divide off the 40. It's going to give me 6 on that side. Now, base of E, okay? Natural log, which is LN. Again, do be careful with that inside of Math Lab. Sometimes their L's look like 1s, okay? Natural log also has a base of E. So what's going to happen here is if you are working with a base of E, you are going to use natural log, okay? It's going to make life easier for you. It's not that you can't use common log, but it does make life simpler, okay? These two, again, are going to cancel off. So I have 0.6x equals natural log of 6. I'm going to finish by dividing by 0.6. So we have x equals natural log of 6 over 0.6. Okay, there's our exact answer. And again, if you're going to go to a calculator, natural log is right underneath or really close to your other log button. So you're going to hit natural log of 6. Make sure you close that to say that you're done with that log. Divide by 0.6, and we get 2.986. Okay, so 2.986 would be our decimal approximation if we were needing to, if they asked for that. Okay, they don't always ask for both. Okay, sometimes they will ask for one or the other and not necessarily both. Okay, now then, The next exponential one, okay, is probably going to be the more challenging of the ones that we have to deal with. And when I put it up here, okay, it'll kind of make sense as to why it's going to be a little bit more involved. I should say more involved, not more challenging. Okay. So the concern that we have here that we have not encountered thus far before now is we have x's in both exponents. Now, we dealt with having x's on both sides before, but it was when we could get them matched out to the same base. Now we're dealing with a situation where I do not have, and I'm not going to be able to get them into matched base, and I have x's in both exponents, okay? So here's how we're going to do this. First thing is I need to get this stuff down out of my exponent. So I'm going to bring in log. Now, I'm going to use natural log for this, just so that you can kind of trace and track what I'm doing and where I'm bringing it in as this is going through, instead of log. But you could also use common log, okay? If you're not working with a base of 10 or a base of E, it really does become your preference for which one you want to use, okay? Now, next thing is I need to bring this exponent down, but I need to make sure that I show the entire exponent is coming down and being placed in front, okay? What we don't want to see, okay, is if I do this, it looks like this natural log of 3 is only connected to the 1 back here at the back, and that the 1 would have been the only thing up in the power, okay? This is not what we want to do, okay? Now, the next concern that we have, okay, is that the only way I can move x's around right now would be through multiplying and dividing, and I really don't want to create division yet, okay? So the next step is going to look like it makes it a little bit messier, but it's needed, okay? So we're going to distribute. Okay, so I distributed my natural log of 3 back into both. I also distributed my natural log of 7 back into both. Now, for coming into the next line, I am going to drop the 1s that are in front of these natural logs. I just wanted to show that I actually did that distribution, okay? Now, the benefit of doing that distribution, okay, is that now, because everything is either being added or subtracted on a side, I can move things from one side to the other, or vice versa, using that addition or subtraction. So what I'm going to do is I'm going to bring this x, natural log of 7, this way, since I have a 2x over here. So I need to get rid of this natural log of 3 by adding, and I'm going to subtract this x natural log of 7. So rewriting, I've got 2x natural log of 3 that was already on this side, minus x natural log of 7 equals, and I'm going to just do natural log of 7 plus natural log of 3. Okay, so again, this was to cancel off here and there, okay, to make those go away. Now then, this next trick is kind of a commonplace one. Both of these have x's in them, so I'm going to factor that x out. And then I'm going to take this whole thing in parentheses and I'm going to divide it underneath the other side. Okay, oops, sorry, remove down just a little bit so you can see. There we go. Okay. So now the good news is, guys, If they ask you to do a problem like this, where you've got x's in both exponents, bases that are not going to match, this is kind of your procedure. You're going to put log on both sides, whether it is natural log or common log, that is your choice. You're going to bring those exponents down in front. You're probably going to wind up doing some distribution stuff, okay? You're then going to get all of your x pieces on one side and all of your non-x pieces on the other. Then you're going to factor the x out and then divide this other thing back under, okay? When that goes, okay? So this is kind of your setup for how this is going to work, okay? Now then, this is considered an exact answer. It's an ugly one because it's got lots of logs in it, okay? But that is your exact answer. Now, if you are going to have to do this into decimal, okay? Number one, okay, well, I should say this. It's like eating an elephant. Do it one bite at a time, okay? Do not try and put all of that in a calculator all at one time, because it is going to require lots and lots and lots and lots and lots of parentheses to make it happen. So what I would encourage you to do is get the top, single value. It may be, you know, a long decimal or something like that, but get a single value. Do the bottom and get a single value. Do make sure you're closing your parentheses when you get done. So like after you do this 7, close that set of parentheses that the calculator is going to give you, okay? Then type in the top number divided by the bottom number. And I encourage you to do it that way, so that you have less chance for error with that, okay? The last thing I want y'all to do is have like some error messages that go into you didn't get enough parentheses, or it didn't read right, or whatever else, okay? And it wasn't necessarily because you did your work incorrectly. It was more just like a computational type error where it didn't get put in right, okay? Now, we've got one more type, okay? That's going to be done in exponential, and then we're going to be done with exponential equations, and we'll move over into the log ones, okay? We're going to revisit a friend here. Okay. It's our lovely, pretty little friend, quadratic looking, okay? We haven't seen these since section 1.6. I know y'all love that section so much. Not really. Y'all didn't like it. I'm not the hugest fan of it, but you know, it happens, okay? So if you remember with that one, okay, and I'm going to try and move myself over here. This is the one where we did a replacement. So I'm going to pick the letter U, and remember that this is usually the variable thing here in the middle. So I'm going to make that e to the x. I'll zoom in here in just a second. So u squared is going to be e to the x squared. Okay. Now then, powers raised to powers is multiplication. So that is e to the 2x, which is what we have up here in the front. So looking, I have e to the 2x, which is u squared, minus 4 e to the x, here is u, plus 3, and we're going to set that equal to 0. Okay. Now then, at this point, you can either do quadratic formula, complete the square, whatever you want to do with it. It will factor, okay? So it will factor to u minus 3, u minus 1. I'm going to take each of those pieces and set them equal to 0. I'm going to add the 3, and I'm going to add the 1. Now, here's the problem. If you put 3 and 1 in, it's going to tell you no, okay? Guys, the original problem was written in terms of x. You aren't at x's here, okay? So you need to now leave, okay? I think I referenced it like leaving Chuck E. Cheese, okay? It's time to get the money, or leaving a country in Europe that uses euros, okay? It is now time, okay, to convert back. So this is going to be e to the x equals 3, and e to the x equals 1, okay? Now, guys, this should feel similar kind of to the one that we did 2 problems ago, When I have a base of e, the next thing that I want to put into place is I want to take natural log on both sides. Okay. And again, the natural log of e's will go away. So I have x equals natural log of 3, and x equals the natural log of 1. Now, perfectly acceptable answer. MATLAB won't take this. Okay, and the reason is the natural log of 1, if you put, now I'm trying to pull this in here, natural log of 1 on a calculator, it is 0. 0 is a pretty answer. It is going to be expected, okay, that if you have pretty answers like 0 or 2 or half, you are expected to do those, okay? Natural log, this one, natural log of 3 is not a pretty answer, okay? It's a decimal thing. So we're going to leave natural log of 3 the way it sits. But if something will go down to a pretty answer, like a whole value or a nice fraction, it's probably going to be in your best bet that you actually answer with that format, okay? That it's in that nicer, prettier version, okay? So that is the run on how to do exponentials, okay? The second part of this unit, okay, or this section, we're still in 4.4, is going to be log equations, okay? And remember, guys, if you have questions at any time, stick them in chat, stick them over there in that chat thing, and I will try and answer them just as quickly as I possibly can. Okay, so now for log equations, we again have 2 ways that we're going to do this. The first one is going to be switching format, okay? Now, if you have watched the video from section 4.2, when we first discussed logs and we talk about doing that E-loop, okay? Doing the E-loop thing where you are getting out of log form into exponential. That is what we're talking about here where we're going to do this switch format. We're going to do that E-loop thing, okay? The second option is going to be if we have logs on both sides, okay? And we'll talk about how to deal with that one, okay? So, talking about the switching format version of this, okay? If you have log on one side, or it can be arranged or condensed. Now, you may have to do some condensing to a log on one side, okay? Then you're going to use the switch format. And remember that for the format for this, okay, so if we have something that looks like this, you start here and you loop through. So you would have B to the C equals M, okay? And remember that oftentimes it is easier to solve these exponential equations than it is for you to think about a log. Now, one of the other things to remember about log equations is you cannot take the log of a negative number, okay? So I cannot have log, and this is something like -4, okay? You cannot take the log of a negative number. You also cannot take the log of 0. So we do have to watch some of these as we are processing through, okay? So taking a look. Okay, so starting off kind of nice and simple here. I've got a single log on one side, single piece on the other. So what we're going to do is we're going to loop through. Okay, so I had 2. The next thing I hit was the 3 equals x minus 4. 2 cubed is 8. We're going to add that 4 back over to the other side. So we have x is 12. Now, we do need to check this going back in. So we're going to take 12 and plug it in up here. 12 minus 4 is 8. We're taking the log of 8, and that is okay. I'm not necessarily needing to plug it all the way in and verify that it works. This is more so that we are not causing anything to become a negative value on the inside or something like that, okay? So now, another one, looking at another one. Now, with this one, y'all, I need to make this 4 go away. Now, I have 2 options. One is, okay, I can send it back up as a power. I'm just going to have to deal with a 4th power later on. The second option, though, is if it will divide pretty onto the other side, I'm going to divide. In this case, it will. So I'm going to divide by 4. Okay. Now, doing my loop-de-loop. Now, remember, on natural log, the base on natural log is E. Okay, so my base here was E. I looped through the 2 and then into the 3x. In order to finish solving for x, I need to divide by 3. So you can either write that as e squared over 3, or you could do 1/3 e squared. Okay, that kind of becomes your choice. Again, checking this back in, if I send this back in, the divide by 3 times by 3, or the 1/3 times 3 is going to go away. I've got e squared. Guys, e is that 2.7 number, which means when I square it, it's still going to be positive. Okay, so that is going to work, and I'm not going to have any concerns or issues there. Okay, so now, another one. Okay, so this is one of the ones where I was talking about it can be arranged or condensed. Okay, guys, I got too many log words here. Okay, so thinking about our condensing stuff that came out of section 4.3, addition goes back to multiplication. So I'm going to have x times x minus 3. And I'm going to put a set of brackets around that just to show that that is all inside of the same log. Okay, and again, all that is condensing. Now we're going to loop that through. Sorry, I'm missing some parentheses. Now, this is common log. Remember that the base on common log is 10 to the first equals, and then I have this x times x minus 3. Okay. So 10 to the first is 10. And then if I distribute over here, guys, this is looking quadratic. Okay, so I'm going to move everything over to the same side. We're now going to try and solve this. You can do quadratic formula, complete the square, whatever you like. It will factor, okay? My brain intuitively heads towards factoring when I do stuff like this. But again, if you are not super comfortable with the factoring, you have the other options, okay? So now I'm going to take each set and set it equal to 0. Now then, it is certainly possible to have 2 answers. It's not super common, but okay. And this is a scenario where it is super important to make sure that you check your stuff, okay? So if I take the number 5 and I plug it back in, log of 5, we'll be okay with that. 5 minus 3 is 2. We're okay with that, okay? So I'm cool with 5 being an answer. Now, if I take negative 2, if I plug it in up here, that is log of negative 2. That can't happen. This is automatically out, okay? Now then, I have seen scenarios with this, okay? Just so that, you know, and guys, I don't want you to get frustrated with your homework stuff, okay? Because here's the deal. Let's say that you worked this down to 2 answers, okay? and you put in 5 and -2 as solutions, and it came back and said, sorry, that's incorrect. And then you plugged in 5 by itself, okay? And let's say that it didn't work, okay? So it said no. And you plugged in -2 on its own. You have now used your 3 strikes, okay? That's your 3 chances because it was something like no solution, okay? I have seen these problems where when I get 2 answers, both answers work. I have seen them where one works, but the other one does not. And I have seen them where there are no solutions, okay? So I need you to understand that take the extra 10 seconds, okay? Take those extra 10 seconds and check your stuff back in and make sure. Now, with that being said, okay, I want you to know, and I'm going to create kind of just a dummy problem here, okay? If you get something, okay, let's say you had something like x plus 7 equals 2, okay, something like this, okay? Let's say that you work this down, and guys, I don't know what the actual answer is, but let's pretend that you got an answer like -3, okay? Do not automatically mark out -3, okay? Just because, oh my gosh, it's a negative, and negatives can't work with logs. Guys, look what happens. -3, when you plug it back in, -3 plus 7 is 4. You would actually be taking the log of 4, which is fine, okay? So do not automatically go, oh, it's a negative number answer. It can't be true. That is not always the scenario, okay? It depends on what's happening up here. Are we adding some stuff to it? Is there, and by the same token, y'all, if that was a minus and I got 3, 3 minus 7 is -4. That means that can't be an answer, okay? So do not automatically assume that just because you get a positive or a negative something, okay, that it can or can't be a solution, okay? So let's take a look at another. Okay, so now moving into the other top. Very similar, if you remember we had the rule, okay? We just had this rule at the very beginning of the section, okay? B to the M equals B to the N, M has to equal N, okay? Now then, we have the same type of thing in the log format, okay? So if I have log base B of M and log base B of N, then I can basically get rid of the log words and I have M equals N, okay? Now, again, make sure that you are condensing, okay? Please, 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 please. Make sure that you are condensing. Now, let's take a look at one of these lovelies. Okay, sorry. That's over there just a little bit. Don't worry, I'm going to make this clean up real pretty here in just a second, okay? Now then, I do see that I have logs on both sides, okay? The problem is that I've got an extra one over there, okay? So we need to condense this side. Now, question comes up. We did condensing on the last one. Oh, subtraction goes back to division, okay? Okay, now, the question comes up, how am I supposed to know, okay, when the condensing is going to lead me to something where I'm going to switch formats or not, okay? Here is the clue. If every single piece has the word log on it, it is going to be a log on both sides problem. If every single piece has the word log or ln or log on it, it's going to be a log on both sides. Now, you may have to condense some stuff down to make it happen, but you're going to have log on both sides. Now, if there is any one item, and if you go back and look at the examples that I just did on that switching format, if there is any one item that does not have a log word on it, you are going to wind up doing that little e-loop switch. Okay, you're going to use a switch format. That is the easiest way for me to explain how to do that. Okay, so now I have log on both sides. I can cancel off that log stuff. So now I have x minus 3 equals 7x minus 23 over x plus 1. Okay, now I don't want this fraction, so I am going to multiply by x plus 1, and I'm going to stick this in a set of parentheses, okay, to bring this over. Foiling or multiplying this out, x squared okay, and again, I'm saying that this is going quadratic, so I'm going to clean this up. So I have x squared minus 2x minus 3, 7x minus 23. I'm going to bring it all to one side, so I'm going to subtract this 7x over to the other side, so that it's going to be minus 9x. I'm going to add the 23, so it's going to make positive 20. Again, now you can do quadratic formula, whatever else, okay? It will factor. Okay, now again, we are checking whether or not, okay, we're going to have concerns or issues. So when I take the number 4, 4 minus 3 is 1. We're okay with that. 7 times 4 is 28. Minus 23 is 5. We're okay with that. And 4 plus 1 is 5. Okay, we're good with that one. 5. 5 minus 3 is 2, so we're good there. 7 times 5 is 35. Minus 23 is 12, so we're good there. 5 plus 1 is 6. So we actually get that both of these work for this one, okay? Again, guys, what I would hate for you to do is to have done all of this math, okay, through here. You get 4 and 5 and you go, oh, I know these problems. It's one or the other or it's no solution. I never have 2 solution answers, okay? And so you put 4 in by itself and it comes back and tells you, sorry, that's incorrect. And then you plug in 5 by itself and it comes back and tells you, sorry, that's incorrect. So you try no solution. It says, sorry, that's incorrect. The correct response was 4 and 5. Now you've done all this math, okay? And now you're going to have to do it again, okay? Because of the fact that you were not willing to take that extra, like I said, 10, 15 seconds to plug it in and make sure that stuff was going to process out, okay? Now, one of the other, okay, things where this comes into play, okay, and this is going back and looking at, okay, we're going to go back and look at our compound interest formula here for just a second, okay? Okay, now what's going to happen with this is, the reason that we're revisiting is because we now know how to solve for variables and exponents, okay, more often they're going to be talking about figuring out what this time is, okay? So it asks, how long to the nearest 10th of a year will it take $1,000 to move to $3,600 if we get 8% compounded quarterly? Okay, so filling in our pieces that we know, 3,600 is the amount that I want to end with. 1,000 is the amount that we started with. Our rate is 8%. Remember that that's got to be done in decimal. N is the number of compoundings. It says quarterly, so that's 4. And I have 4t up there. So now, cleaning up, I'm going to divide off the 1,000. It's going to be 3.6. Cleaning this part up, that's going to be 1.02 to the 4t. Now, guys, hopefully you kind of recognize that that this looks very, very familiar to the, I'm not going to be able to match my basis, so I'm going to have to bring a natural or a log in. I'm going to bring in natural log. Again, this is primarily to show where stuff is moving to, okay? Okay, and now we're going to divide off. Now, guys, I can divide off the 4 and the natural log all at the same time because it is all multiplication. Now, here's the deal, guys. This is a scenario where if somebody walks up to me and says, I got $1,000 to invest. I want it to be $3,600. I got 8% compounded quarterly. How long is it going to take? The response, and even if you walked into a bank, okay, their response is not going to be, well, it's going to take you natural log of 3.6 divided by 4 natural log of 1.02 years. That is not the way that is supposed to be said, okay? This is an instance where they are not going to want an exact answer. They are going to want a decimal approximation. So let's talk about putting this in on a calculator, okay? So I'm going to do natural log of 3.6. Close that. I'm going to press enter, okay? That's the top. Now, I'm going to do 4 natural log of 1.02. Okay. Now, if you have a calculator like one of these graphers where you can scroll up and grab, okay, then I encourage you to scroll up and grab the top number and then do divided by the bottom number. Okay. So, and it said 1/10 of a year, so we would say 16.2. Now, if you did not have that option, guys, you still have the ability to hand type the stuff in and you will get the exact same response, okay? So the answer for this one is 16.2 years, okay? Now, this is helpful if I'm looking at something like how can I, if I wanted to do like a college investment and I wanted to put $1,000 in when the child was born, and I wanted to have $3,600 to get them started to go to college, would it be enough? Okay, and at 16.2 years, yes, because the kid probably hasn't graduated high school yet. Okay, this may be something like if I got an inheritance and I was wanting to do something like I want to have an extra $500,000 for retirement. Okay, if I figure out that it's going to take, okay, 50 years to get up to that $500,000, then it's probably not going to be something that I can have that $500,000, okay? Because it's just going to take too long. And unless I invest it sometime when I'm in like my teens or my 20s, that 50 years is not going to make it before I hit retirement at like 65 or 70, okay? However, if I can get that amount of money, how much it is, $10,000, whatever, $50,000, whatever it is, if it will grow, okay, in say 25 years, okay, then in theory, you could invest that, okay, even if you acquired it sometime into, you know, maybe your mid to late 30s, you might could have that happen, okay? So this is where this formula comes into play to kind of help out and make this happen, okay? So now then, next section, okay? So now we're going to do section 4.5, okay? And this is exponential growth and decay. Now, the formula for exponential growth and decay looks like this. Now, guys, that should look semi-familiar. Back when we did section 4.1, we had A equals P e to the RT, okay? That compound interest formula is a version of exponential growth and decay. Now, one of the things that's nice about this setup, if K is positive, it's growth. If K is negative, it's decay. It's that simple, okay? It's either growth or decay, and it's easy to tell. If the K value up here is positive, then it's growing and getting bigger. If the K value up here is negative, then it's decay and it's getting smaller, okay? And again, growth graphs look like this. Decay graphs look like this, okay? Now then, we're going to see a couple of different examples with this. Now, generally, these equations all work the same way. They are going to give you a starting amount. They are going to give you a secondary amount with some sort of a time frame. And the first thing that you're going to be asked to do is solve for K. After that, they usually ask one of two questions when this happens, okay? So here's what we've got. In 2000, okay, okay, so in 2000, the population of Africa was 807 million, okay? In 2011, it was 1,052 million, okay, which is actually 1,052,000,000, okay? They ask us to find an exponential growth model where T is years after 2000, okay? And that's because we want to use this 2000 as a starter value, okay? So the way this works is, okay, this 807 is going to be my A naught. This 1052 is going to be my A, and then I'm going to figure out T. So I have working into I have 1052. Now, it has from 2000 to 2011, T is 11. Okay. Now then, solving for this, I'm going to divide by 807. Okay. Because I'm working with E, I'm going to use natural log. Again, those two are going to cross off. Okay. I'm going to move over here. So now I have natural log of this 1052 over 807 equals 11. Okay. I'm going to divide by 11. Okay. Now, this is a spot where we kind of want to be a little more precision. Okay. So I'm going to do this in not super, super small chunks. Okay. But I will do it in slightly smaller chunks. So I can do natural log 1052 divided by 807. Okay. You can do all of that inside of the same log. Just make sure that you keep it all in the same set of parentheses. Okay. So I'm going to get that answer. And then I'm going to divide by 11. Okay. Now, you are probably going to get decimal numbers. Okay. You are probably going to get legit decimal numbers for K. So K is, I'm going to do 0.0241. Okay. So my equation is 807 E 0.0241 T. Okay, I'm going to slide that down, see a little bit. There we go. Okay, now notice I am still using 807 as that starter amount. Okay, I'm still using 807 as the starter. I just now have this K value sorted out. Okay. Now, within this, okay, and the next thing that I'm moving to with this is still going to keep the same thing. So I'm going to move my equation up here to the top. So our equation was okay, so this was our equation. They're going to ask one of two things. okay? They are either going to give you a time, a T, to plug in. So they would say something like, what would the population be in 2018? Okay, well, 2018 is 18 years after, so I'd be plugging in 18 here, and you would just process this through that way, okay? The secondary option, okay, the second type of question is they're going to say something like, when will it reach a population of, or when will it reach a certain value, okay? So they ask when, so, and they actually do for the second part of this question, they ask the second part, they ask, when will it reach 2,000 million, okay, which is actually 2 billion. Now, we're going to set this up. Now, the steps are going to look very, very similar to the ones that we just did. We're going to divide off the 807. I need to get rid of E, so we're going to bring in natural log. Again, these are going to cross off. So I have natural log of. Now, you may be asking, why am I leaving this in 2000 over 807, or why did I leave it in the 1052 over 807? I do it because I don't want to have to write out a big long decimal thing right now if I'm kind of showing my steps. And then we're going to divide this underneath. So I'm going to have natural log of 2000 over 807 over 0.0241. And that's going to be T. Okay. So again, going to our calculator here, I'm going to do natural log of 2000. I also want to keep stuff as accurate as possible as I can. Okay, so we get T is 37.659. Okay, so since this is years after 2037 or 2038, kind of is your take on whether or not this 0.69 takes place in 2007, or if that is after 2037 is ended and it's into the 2038 year, okay? So that kind of becomes kind of which one I would take either answer, okay? With that being said for that one, okay? Now, the next application that we see done with this, okay, is I'm pretty sure it's a chemistry reference, okay? And it's this thing called half-life, okay? Every chemical element has what's called a half-life, and it's the amount of time that it takes for half of our stuff to go. So I'm going to pick an easy number here, 100, okay? If we go 1 half-life, however long that is, we're going to have 50, okay? It's half of what we had. Now, if we go another half-life, it is not going down to 0. It's half of what I have, okay? So if a half-life is 10 years, after 10 years, if I had 100 pounds of this, I would have 50 left. After another 10 years, I would now have 25 pounds of it left. And then I would have 12.5 pounds and so on and so forth, okay? So it's not just after 2 half-lives, it's all gone, okay? It is always half of the amount that I have, okay? So they give us an equation. They were nice, and they gave us one. That this is the half-life for strontium-90, okay? And it says there was originally 60 grams, okay? And they want to know, when will we reach 10 grams, okay? Okay. Now then, the other thing that I have seen them done, just so that you understand how they do this, sometimes they will use percentage stuff, and they'll say something like, there is 40% of something left. Okay, guys, the easiest way to do that is say that there was 100 grams of it first, and now there's 40 left. Okay, so if they do percentages, just use 100 for your A naught. So here we go. We're going to put in 10. We're going to put in 60. Okay. I'm going to divide by 60. Now, I did reduce that fraction to 1/6. It just made it a little bit easier. I'm going to bring in natural log on both sides. Again, natural log is going to cross off. So now I have natural log of 1/6 equals our negative 0.0248t. I'm going to divide that. Okay. So bringing that in with our calculator, natural log of 1/6. Okay. And then we're going to divide by negative 0.0248. And we get that it is 72.248. Okay. Now, they don't specify whether that is years, months, days, whatever else. Normally, they will specify that time is in years or time is in months or whatever else. Whatever unit of measure they do, that would be what we would tack on to the end of that. Okay. Now then, another type of model that is handled, okay, in this is what's called logistic growth. Okay. The formula for this, okay, looks like this. Okay, A equals. Now, guys, this example could not come at a better time. Okay. The way logistic growth models work is there is a cap limit on stuff. Okay, and that's what the C represents up here at the top. That is a cap limit. This is kind of like, this is with COVID-19 running around right now. This is a really great model. If you have, okay, a particular town, okay, and let's say that there were 30,000 people in this town, what's going to happen here is if you get, and I'm not going to use COVID-19, okay, I'm going to use just like the regular flu, okay, the regular flu. What happens is you have a few people that start off getting sick, okay, so it's processing along, and some other people are getting sick, and then you start to see that it increases. Now, what we're keeping track of here is how many total people have been sick, okay? So what's going to happen is the total number of people that have been sick is going to start to rise, but if we're keeping track on the town, eventually, guys, what's going to happen is it's going to level back off because there's this understood cap limit, okay, of, like I said, there was like 30,000 people in the town. You can't have more than 30,000 people get sick, okay? So like I said, it starts off slow, and then again, this is keeping a total count of what was going on here, and then it's going to level back off as we get up into the top end. Now, the good news is with this, you are generally only asked, okay, to plug in values into this, okay? So the example that they give us is, okay, so they give us this equation, okay, and this is the proportion of correct responses after T learning trials, okay? So maybe this is students are learning how to, I don't know, factor, okay? And so they give them a problem and ask them to factor it, and then they show them a learning video about it, okay? Or they have a teacher come in and teach a lesson, and then they try them again. And then they come in and they teach another lesson. And they look, and this is the proportion of correct answers to a particular problem. Now, it asks, find the proportion of correct responses prior to the trials taking place. If it wants prior to the trials taking place, then T is going to be 0, okay, because they haven't done anything yet. So we're just going to plug this in. Okay, and I'm going to do a little bit of step-by-step here. Okay, negative 0.2 times 0 is going to be 0. Guys, anything to the 0 power is 1. Okay, it's going to be 0.8 divided by 2, and that is going to be 0.4. Okay, so 0.4 of the trials will come out, or 40% if that was getting roughed out into percentages. Okay, so hopefully, and again with these, generally you're doing plug and chug, so they could ask something like, what percentage would it be after 2 trials? If it was after 2, then I would plug in a 2 right here and then work down. Okay, so this one is more of a just an application type thing that you may possibly see done. Okay, now the last thing that we've got to handle, okay, is if we have something that is written AB to the X, this is the same as this, okay? Now, you may be going, well, why does it matter? Okay, here's the deal. When we talk about populations, okay, and I'm going to pick 2 countries here. I'm going to pick Luxembourg, which is kind of a small country, and I'm going to pick China, okay? Now, if I say that there were 1 million children born into both countries in a year, okay, and I want to know whether that is growing. I want to know whether or not that's grow and how much of a growing pattern it is. Guys, in a place like Luxembourg, okay, which is not a very large country, 1 million babies might be something like maybe a 1 or a 2% increase in population. In China, though, 1 million babies might not be an increase in population at all. You may have more people, okay, more than 1 million people passed away, moved out, whatever else, over the course of that year. So I need to not talk about it as 1 million babies born. I need to be in terms of that country as a whole, okay? And the problem when we look at something like this is it's really, really difficult to tell. Okay, I can get whether it's growing or I can get whether it's increasing or decreasing. Remember, if B is greater than 1, it's increasing. If B is between 0 and 1, it's decreasing. But I don't have this idea of being able to compare, okay? If I have it in this format, this value up here, this natural log of B, notice this looks like A naught E K T. Guys, with that K, if the K is positive, we know it's growing. If K is negative, we know it's decreasing. The other part of that is the higher the K value, either if it's more positive, then it's growing faster. If it's more negative, it's decreasing faster, okay? So it's helpful, okay, to be able to look so that then you can do comparisons, okay? So if we have a problem, okay, and they ask us to write this in terms of base E, okay, it's going to be 4E natural log 7.8 and then X, okay? Now, if they wanted an exact, that's fine. But if we go ahead on our calculator and we do natural log of 7.8, we get 2.054. Okay, now I know that this population, whatever this is growing because this is a positive number. It's also a fairly large positive number, so it's probably growing really, really fast. Okay, so now looking at, okay, a couple more of these. Okay, let's say Okay. Okay. Now, with this, guys, I can't tell who's growing the fastest, who's losing the fastest, anything like that, okay? So, if we do, I'm going to move this over just a little bit so I can rewrite, okay? Now, I'm going to go ahead and do natural log of 1.008 on my calculator, okay? And I get 0.0079, sorry, I'm trying to squish this in and I don't need to. 0.00797, okay? Now, if I do the next one, I'm going to do natural log of 1.019, and I get 0.01882. And doing the next one, I'm going to do natural log of 0.994, and I get negative 0.00602. And natural log of 0.995, I get negative 0.00501. Okay, so here's what I now know. India and Iraq are growing. Iraq is growing faster than India, though, because this number, the 0.01882, is higher than the 0.00797. Japan and Russia are decreasing, okay, and Japan is decreasing faster because 0.006 is more than 0.005, okay? So it's a way for you to now do comparisons, okay, between values that may not have started out with the same basing, okay? So I hope that this has been informative for you guys. Like I said, I will push something out on Canvas here towards the little bit later this week on how I'm going to handle tests and all that good kind of stuff. I'm also going to host a session on Friday at 5 o'clock. I think I'm going to do it at 5 over the last couple of sections that are handled. That way, all of the videos are up. You have access to them, and y'all can keep working on homeworks and stuff like that, okay? Hope you guys have a great rest of your evening.